Hey everybody, this is your continuation of the 5-4 notes. I did have to change the problem numbers assigned because the book didn't match my resource. So we're doing 1 to 25 every other odd, then 33, 35, 39, 45, and 47. So that's just what we need to do. So to start with, number 21, what we're doing is the integral from square root of 2 to 1 of u to the 7th over 2 minus 1 over u to the 5th du. Now first, before anything, remember square root of 2 is approximately 1.414, and so this is like backwards. So we might end up having to change it to a negative and then flip these. So let's see what we do. So the first part is we want to change this to the square root of 2 to 1 of u to the 7th over 2 minus u to the negative 5. So remember, if it's 1 over a power, then it just changes sign. From there, we need to do the integral. So if you have u to the 7th, the integral of u to the 7th would be raise the power to 8 and then do 1 over that. Okay, so this is going from square root of 2 to 1. You keep the 1/2 in front, and then we need a 1/8 u to the 8th. Okay. Now on the next part, we have u to the negative 5. And so, like, what we've been doing is the integral raises the power by 1. Now, when you have a negative 5, that's going to end up going to negative 4. So that's how that works. And then you're going to need 1 over that. So remember, if you have u to the negative 5, it would go to negative 4, not to negative 6. Okay, so that's what we're going to end up doing over here. So we have minus 1 over 4u to the 4th. Let's just keep it in that format. Okay, so let's see, let's just change this to a bracket because we've already done the integral. Change this to a bracket and go from square root of 2 to 1. Okay. They kept it in the same order, so I guess we'll do the same thing. We plug the 1 in, and make this 1/16. 1/16 u to the 8th minus 1 over 4 u to the 4th. Okay, we're going to do that from square root of 2 to 1. Okay, plug in the 1 in both places, and so we have 1/16 times 1 cubed minus 1/4 times 1 to the 4th. So those just stay that way. This was 1/16 1 to the 8th. Excuse me. And then for this part, we need the square root of 2 to go in here. So we've got 1/16 times the square root of u, well, square root of 2, sorry, square root of 2 raised to the 8th power plus 1 over 4 square root of 2 to the 4th power. Okay, so let's use the calculator for that. So to start with, we have 1/16 minus 1/4, that's negative 3/16 minus parentheses. Okay, I think the easiest way to type this would be, say, square root of 2 raised to the 16th power, no, raised to the 8th power, and then divide by 16. Well, that just gives you 1. So here we have 1 plus, okay, this one we need 1 over 4 square root of 2. Now the square root of 2 part goes to the 4th power, not the whole thing. So you need to put the extra parentheses and raise to the power. And so I get 1/16 there. Okay, now you could distribute the minus sign or just type it that way and see what you get. So negative 3/16 minus 1, and I'm going to say minus 1/16. That gives me negative 5/4. Okay, what I just realized is that when we did this part about making it go from 5 to 4, that this needed to be a negative 4 down here. So that basically changes all these signs to plus. And yeah. Okay, so let's make sure this is right. Okay, we need 1/16 plus 1/4. That gives you 5/16. And then let's see how this part works out. Square root of 2 to the 8th was 16, divided by 16 was 1, so that's still 1. And then on this part, we need 1 divided by 4 and square root of 2 to the 4th power. And so that gives you 1/16. Okay, so this will be 5/16 minus 1 minus 1/16, and that gives you negative 3/4. And that's what we want. Negative 3/4. Okay. So be sure you remember that when you're taking like a number, that you raise it to the power. Like if it's positive, keep it positive, but if it's negative, keep it negative. So this is since negative 4 is the power. Then divide by negative 4. So that's why that has to be that way. Okay, so next after 21 we have 25. On 25, the problem says do the integral from pi halves to pi, sine of the double angle, so sine 2x, divide by 2 sine x dx. Okay, so the first thing is you may have to recall the double angle formula. And if it's sine of the double angle, it's 2 times sine times cosine. So that's what we have to substitute in. So this is 2 sine x cosine x over 2 sine x. Well, once you get through that step, then you can see the 2 sine x is going to cancel and need a dx here. So then those cancel, so you just have cosine x dx. And this is from pi halves to pi. Okay, so then remember that the derivative of sine is cosine, which means the integral of cosine is sine. So that's how those are related. Remember, it's kind of like inverses. So when we do the integral of cosine, we get sine. So I now have a bracket there because I did the integral, and then now I need to use the interval from pi halves to pi. Okay, so this would be sine of pi minus sine of pi halves. All right, so for pi, that's over here, and so that's 0. And for pi halves, that's here, so I get 1, and so negative 1 is my answer. Remember, sometimes these numbers change and the formulas change, like from sine to cosine. So you might have to do a cosine double angle formula, or you could actually be really lucky. Like on 17, I noticed that they kept the problem on Math Excel the same for somebody. Yours might have a change, but this was 0 to pi eighths of sine 2x. So with all that work, it was the same answer. So sometimes you may be lucky like that. Sometimes they change it. Okay, so that was 25 that we finished. The next one is 33, then 35. So on 33, the set of instructions for this says find the derivatives in exercises 33 to 38. A is by evaluating the integral and differentiating the result, and then by differentiating the integral directly. So the directions, I'm just doing this for my purpose. For part A, by evaluating the integral. Remember when we say integral, that's like the little snake, so to speak. It's like the opposite of derivative. And if you want to talk about English, it's a synonym of antiderivative. So antiderivative and integral mean the same thing. Now, when we talk about interval with a v, that'd be like, oh, I want to go from 0 to pi, or just whatever, as a random example. Okay, so with the g, it's like this, and with a v, it's like some domain or range. Okay, so the directions say by evaluating the integral and differentiating the result. So that's part A. And part B says by differentiating the integral directly. So those are your directions. So there's two parts to this. So for 33, let me just put it down here. We're doing the derivative of the integral from 0 to square root of x of cosine t dt. Okay, so basically you're undoing something that's done, and so this one should just end up being, well, for part A, if we evaluate the integral first, the integral of cosine is sine. And so first thing we're going to do over here is put sine of t, and we have to evaluate that from 0 to the square root of x. So you're basically going to change t to be square root of x. So we have sine square root of x minus sine of 0. So remember again that if you're at 0 degrees or radians, the ordered pair is 1, 0. So the cosine would be 1 and the sine is 0. So this is like just saying sine square root of x minus 0, which is just sine square root of x. Now, we evaluated that, and now when we do the other part of it, that implies the little double equal with the line is like implies. What that implies is that the derivative of the integral of cosine t dt. So it's kind of like circular. So since you got sine, that implies this gives you sine. Or if you see sine, it gives you this. Now, when we do the derivative of this, we have the derivative with respect to x of sine square root of x. Think of that as x to the half power. And so if you're doing the derivative of sine to the x to the half power, that's going to be cosine of x to the half power, which is square root of x basically, times the derivative of the inside, and that's going to be 1 over 2, so 1/2 x, and lower by a number, so you lower it from 1/2 to be -1/2. Okay, so when you simplify this, this turns into cosine of square root of x over 2 square root of x. And so that's your answer for A. Okay, for part B, you have the derivative with respect to x of the integral 0 to square root of x of cosine t dt. So what this gives you is just cosine square root of x times the derivative with respect to x of square root of x. and then minus 0. So this gives you cosine square root of x. So the derivative of x to the half, again, we kind of did this earlier. The derivative of x to the half is a half x to the negative a half. So 1/2 x to the negative a half. And so when you simplify that, you get cosine square root of x over 2 square root of x. So if you did it right, these two are supposed to match. So that's the correct answer. But you may wonder, what about this 0 part? Because we did plug in square root of x. Why don't you have to plug in 0? Well, when you plug in 0, let me just do this to the side. When t equals 0, here's what happens. First off, we know the cosine of 0 is 1, not 0, and so it doesn't just go away that easily. But what happens is you do cosine of 0 times 0.5 times 0 to the negative 0.5, and that's undefined. So let me show you that. So when you do cosine of 0 times a half times 0 to the negative 0.5, that's undefined. So that was my way of typing it in the calculator, because to me it's easier to type 0.5 instead of 1/2. But it's basically this. Okay, so we put 0.5, then we put 0, and then raise it to the negative 0.5 power. And because this is undefined, we leave this part out. Okay, so there's number 33. Okay, the next one we said was 35. And on 35, we have the derivative with respect to t, which basically just means we're going to use the t variable. And then we do the integral 0 to t to the 4th of the square root of u du. This is probably setting you up to know about u substitution. So this could be about u substitution. So to just briefly talk about that, if you had the integral of square root of x plus 1, then you could let u equal x plus 1 and then call this integral of the square root of u, which could be related to this. So I think that's what we're going to be talking about a little bit, just as a highlight. We may not have too much time on that, but that's an overview. So what we do for part A is we're doing the integral from 0 to t to the 4th of the square root of u du. We need to change the format of that to be 0 to t to the 4th of u to the 1/2 du, and then you have to evaluate it. Okay, so this is where, again, you might need to work a little bit to the side. If you have u to the 1/2, the integral would go up a power, so that'd be u to the 3/2, and then you got to put the 2/3, because you got to do basically 1 over 3/2, which is really 2/3. So that's how that would end up working over here. So this needs to turn into 2/3 u to the 3/2 and evaluate that from 0 to t to the 4th. Okay, so what this is 2/3. Instead of putting u, we put t to the 4th. So parentheses t to the 4th to the 3/2 power minus 0 to the 3/2 would be 0, so that part just goes away. So now we need to simplify that, and so this would be 2/3 t. Okay, think about a power to a power, multiply your power. So 4 times 3 is 12, divided by 2 is 6. So we have 2/3 t to the 6th. Now that implies the original, which was the derivative with respect to t of the integral 0 to t to the 4th of square root of u du. So that's the derivative with respect to t of 2/3 t to the 6th. And when we do the derivative of this, think about the derivative of t to the 6th would be 6t to the 5th. So when you do the derivative of this, it goes down a level and your exponent becomes your coefficient. So when we do this derivative, we keep the 2/3 there, and then we put it t to the 5th, and then we put a 6. So then 2/3 of 6 would be 4, so you get 4t to the 5th. Okay, for part B, we do the derivative with respect to t of the integral 0 to t to the 4th square root of u du, and so then we substitute in, and so this would be the square root of t to the 4th. Then you need the derivative with respect to t of t to the 4th. So the square root of t to the 4th would be t squared, and then the derivative of t to the 4th would be 4t cubed. And so now here you have 4, and this one is not a power to a power like the other one. This is, if you have like bases, you add your exponents. So then 2 plus 3 is 5, so you have 4t to the 5th. And again, if you did it right, these should match. Okay, so there's 35. 39 is our next one. Okay, on 39, this just says find dy dx. And so we have y equal the integral 0 to x of the square root of 1 plus t squared dt. So basically your dy dx, which is the same thing as the y prime, just is like the square root of 1 plus x squared minus let's see, you'd have minus the square root of 1, which is 1. Okay, I checked, and that's all we do for this one. That's going to be a good stopping point for this video.